Okay, chemistry kids, we are going to do some more unit conversions today, and we're going to talk about density as well today. So today we're going to do some mixed units where we're throwing in the English system as well as the metric system. So here we go. Convert Kevin Durant's height 6 feet 9 inches to meters. What makes this problem a little bit more difficult? So I think there are two things that make it more difficult. In this, we're mixing the metric system with the English system. That makes it a little bit more difficult. And the other thing that makes it more difficult is the English system is I think it's more difficult. I've got feet and inches. So the thing that we really have to do is we've got to make Kevin Durant's height into either just feet or just inches so that we can do this conversion. So I propose that getting his height completely in inches is the best way to go, because on my conversion that I have here, my conversion is in inches. So that's what I want to use. So let's use inches. So the thing I have to do is convert that 6 feet to inches. So I'm going to use unit analysis. And if I want to make feet into inches, I want inches on top and I want feet on the bottom to cancel out my unit of feet. Now I need to remember how many feet is equal to how many inches. So hopefully you remember that in 1 foot, there are 12 inches. So in 1 foot, I have 12 inches. This way, my units of feet cancel, and I am left with the units of inches. Okay, so when we do this, 6 times 12 will give me 72 inches. Then I have to remember I still have 9 inches here as well. So 72 inches plus the 9 inches will give me a grand total of 81 inches for Kevin Durant's height. Okay, now that I have that height completely in inches, now I can use this conversion factor right here to get it into meters, right? I want to get this into meters. So here we go. We're going to start with our 81 inches. I don't want inches. I have a way to get to inches to centimeters. I want my inches to cancel out, so I'm going to put my 1 inch on the bottom. And I have 2.54 centimeters on top. But I don't want centimeters. I want meters. So I need to remember what my conversion between centimeters and meters are. So centi is 1/100th. So that means I have 100 centimeters in 1 meter. So I'm going to put that 100 centimeters on the bottom because I want my centimeters to cancel out now. So my inches cancel, my centimeters cancel. That's going to equal 1 meter. So I'm left with the unit of meters, which is what I want. Now, mathematically, we're going to look at it this way. Everything that is on the top is a multiplier. Everything that's here on the bottom, we're going to divide by it. So I'm going to take this step by step. We're going to take 81, we're going to multiply it by 2.54, and then we're going to divide that by 100. So that's how we're going to do this problem. So if I take 81, let's turn on my calculator first. 81 times 2.54 divided by 100. So when you do your, that's so glary. When you do your thing, you should be able to have just 81 times 2.54 divided by 100. So when we press enter, our calculator will spit out this. So if we notice, we really only have 2 digits here and 3 digits here and 3 digits here. So we probably should round it about 2 digits. So that 5 tells us to round up. So 2.1 meters. If you want to report all of those digits, you can, but I like to kind of look at how many digits I have and see what's going on. Another thing I really want to highlight here, please notice how I always show my units in my setups. You need to do the same. Remember, the unit you want to get out of always needs to be on the opposite side, top or bottom, in the next step. So I wanted to get out of centimeters. So our centimeters were on the top here, so I put centimeters on the bottom here so that those units could cancel out. Make sure that the units that you want to cancel are on the opposite side in the next step. Okay, so here we go to the next one. The other thing I want to also point out is note. Make sure that your answers make sense. Give yourself kind of a gut check. For instance, it is not uncommon for a student to end up with an answer of 20,574 meters. Can a person really be that tall? Does that make sense for a reasonable basketball player height to be that tall? Mount Everest is only 8,850 meters. So you mean to tell me at that a person is 2.5 times taller than Mount Everest? That's not a reasonable answer, even if they are a basketball player. Okay, so we're going to try a few more. I want to convert Kevin Durant's weight, 240 pounds, to kilograms. So I am going to use this conversion factor where I can use pounds to get into grams. So 1 pound is equal to 454 grams. So here we go. We're going to start with our weight of 240 pounds. And that conversion factor that I just had at the top of the page, it said 1 pound was equal to 454 grams. So I want to put the pound on the bottom so that it cancels out. And I'm going to put the 454 grams on top. Notice my unit of pounds cancels out. And I'm left with grams. But I don't want grams. I want kilograms. So I need to remember how many grams there are in a kilogram. So if I remember, kilo means 1,000 times. So I will have 1,000 grams in 1 kilogram. Okay, so that will take my unit of grams, cancel them out, so I'm left with units of kilograms. So mathematically, once again, everything on the top we are going to multiply by, and everything on the bottom we are going to divide by. So I'm going to take 240, I'm going to multiply it by 454, and then I'm going to divide by 1,000. So when I do that, 240 times 454 divided by 1,000 will give me 108.96. So notice I started with 3 digits here. So if I look at 3 digits, that looks at that 9 to tell me to round. So I'd probably report this as 109 kilograms. Okay? All right. Convert 1 gallon into liters. So let's look at our conversion. I have 946 centimeters cubed in 1 quart. So that's not even gallons. But can I get gallons into quarts? I sure can. Okay, so let's work on this. 1 gallon, I want my gallon to cancel. So I'm going to put gallons on the bottom. 1 gallon is how many quarts? Do you guys remember? It's 4 quarts. Think about it this way. A quart is a quarter, right? A quarter is a fourth, so there will be 4 quarts in a gallon. 1 quart, if I use that equivalence that was at the top, is 946 milliliters. Okay? I want this into liters, right? Ooh, do we remember something about the relationship between milli and liter? Milli means 1,000th. So that means there are 1,000 milliliters in 1 liter. Okay, let's look at my units now. Gallon divided by gallon, so that cancels out. Quart divided by quart, so that cancels out. Milliliter divided by milliliter, so that cancels out. I'm left with the unit of liters, which is exactly what I want. Okay, so we're going to multiply everything on top, and we're going to divide everything on the bottom. So when I look at this, I'm going to take 1 times 4 times 946 divided by 1,000. Okay, so let me plug that into my calculator. 1 times 4 times 946 divided by 1,000. This will give me 3.784 liters. Now notice I started off with 2 digits here. So if I look at just the 2 digits, that 8 is going to tell me to round up. So I would probably write this as 3.8 liters. Okay, how do you do? You doing okay? All right, this one is a pretty complicated one. So this one, we actually have to do 2 conversions. The average velocity of an oxygen molecule at room temperature is 4.0 times 10 to the 4th centimeters per second. So that is 40,000 centimeters per second. Find this velocity in miles per hour. Okay? This problem requires 2 conversions. I have to convert centimeters to miles, and I have to convert seconds to hours. We're going to work on one at a time. First, we're going to work on miles and centimeters. So I have centimeters to inches on this first step. Do you see that? I can use that conversion that was listed at the top of this page of 2.54 centimeters in 1 inch. That will cancel out my centimeters. But I don't want centimeters. I want miles, right? And inches. So I need to figure out how many inches are in a foot. So if we remember from elementary school, I have 12 inches in 1 foot. That cancels out my inches. I'm now in feet. How many feet are in a mile? There's 5,280 feet in 1 mile. So my feet cancel out. I have miles. That's what I want, right? I want miles. So I've got miles. Now I need to work on getting seconds into hours. So notice seconds here is on the bottom. So it needs to be on the top now over here for me to cancel it out. So how many seconds are there in a minute? If you remember, there's 60 seconds in 1 minute. So that will cancel out my units of second. But I don't want seconds. I want hour. So how many minutes are there in an hour? There are 60 minutes in 1 hour. Okay, so there we go. Everything on the top is going to be a multiplier. Everything down here on the bottom is going to be a divider. So we're going to take 4 times 10 to the 4th. And we are going to divide by 2.54. And we are going to divide by 12. And whoa, what happened? And we are going to divide by 5,280. And we are going to multiply now by 60. And we are going to multiply by 60 again. So when we are all said and done, we have a velocity of 894.77 mile per hour on this. So I would probably, we have 2 digits here. That 4 tells me to round down. So I would probably report this as 890 miles per hour. Now you're like, hold up. There's no way that oxygen is moving that fast in the air. It actually is. It's moving at almost 900 miles per hour. The reason we don't feel it is two things. Oxygen molecules are super, super small. And the other thing is that the oxygen molecules are going every which way. So by the time one hits me from this direction and one hits me from this and this and this and this, all of those forces, all those collisions kind of cancel out to be zero. And so that's why we really don't feel like we're being bombarded or hit by the oxygen molecules, even though they are going that fast. Okay, density. The density of an object is actually what we call a derived unit. It's not a unit that is a base unit. We are using two base units to do density. We're using the base unit of mass and volume. So density of an object is mass per. Per means divided by. So our formula then becomes mass divided by volume. Okay. This is not what I want. Okay, so mass divided by volume. Or you could do just mass divided by volume. A lot of times I will tell my students, why does it keep doing this? And if I write it correctly, it kind of looks like a heart. If I continue on these lines, we can pretend it looks like a heart. So density equals mass divided by volume. That's just kind of my little trick here. To measure density, we must be able to measure both the mass and the volume. Mass can easily be measured on a balance. Okay, the volume of a solid can be determined in different ways. For instance, the volume of a cube is the length of an edge cubed to the third power, right? X cubed. The volume of a rectangular solid is the length multiplied by the height multiplied by the width. The volume of a liquid can be found in a clear container graduated to indicate the volume. That's called a graduated cylinder. Okay, I had you read the meniscus of a whole bunch of graduated cylinders in a homework assignment like a week or so ago. When you have an equation, there are two possible ways to solve an equation. Dimensional analysis is what we use. You are really taught the method of equations in your math classes. You are taught to isolate a variable and to solve for that isolated variable. We're going to use dimensional analysis. Okay? Either way is correct. However, dimensional analysis will help you understand what's going on with the units, and that way you won't get tripped up by just plugging in variables into your equation. Okay? So let's look at this. What is the density of a block of lead measuring 4.37 by 6.02 centimeters by 13.68 centimeters? So the very first thing I want to do is I want to calculate the volume. And by calculating the volume, I need to multiply all of these together. Okay? So I'm going to take 4.37 and 6.02 and 13.68, and I'm going to multiply them all together. And when I do that, I get a volume of 359.885. Let's see, 232. Do I really need to write all those digits? Not really. So I have 1, 2, 3, 1, 2, 3, and 1, 2, 3, 4 digits in my original. So I'm probably going to just do 3. That 8 tells me to round up. But if I round up, that 9 becomes a 10. So we are going to round this to 360 centimeters cubed. Okay? And then it has a mass of 4.13 kilograms. The problem with this is we are usually doing density in grams per centimeter cubed. So if I do density is equal to mass divided by volume, I would be tempted to just put 4.103 divided by 360 and be done. But the thing is, that's not the right unit. So I've got to pay attention to my units. My unit on the bottom is exactly what I want, but my unit on the top of kilograms is not what I want. So I want to get it into grams. So let's remember the relationship between kilogram and gram. Kilo means 1,000 of the base unit. So if I have 1 kilogram, that means I have 1,000 of the base unit of grams. So here we go. So I'm going to take 4.103 and I'm going to divide it by 360 and then also multiply that by 1,000. So 4.103 and I'm going to multiply by 1,000 and divide by 360. Okay, I could do either of them. I could do the dividing first or the multiplying first. It really doesn't matter. So I will get 11.397. Now I had 3 digits here and 4 digits here, so we'll probably do 3. So that 9 tells me to round up. So I'm going to call that 11.4 grams per centimeter cubed. Okay, that will be my density. Now, what would be the volume in centimeters cubed of a block of lead that has a mass of 25.3 grams? Now, I can use this density that I just calculated to help me out. I'm going to start out with this 25.3 grams of lead, and I'm just going to put that symbol there so that I know I'm talking about lead, and this is also lead. I can use the grams in this right here to cancel out the grams over here. So I'm going to put the grams in what we figured out here on the bottom. So 11.4 grams of lead will give me 1 centimeter cubed of lead. Okay, so my grams of lead will cancel out, and I'm left with centimeters cubed. That's the unit that I wanted. So I'm going to take 25.3 and I'm going to divide it by 11.4. And that will give me 2.219. I have 3 digits here, 3 digits here. So 1, 2, 3. That 9 tells me to round up. So 2.22 centimeters cubed of lead. That is the units I have left. Okay, so next one. What would be the mass in grams of an irregular piece of lead that has a volume of 45.2? So can I still use this thing to not just get me, here we got a volume, can I use it to get me a mass? I can. So let's see how we do that. So I'm going to take the 45.2 milliliters of lead, and I want my milliliters to cancel. Remember that 1 milliliter is the same as 1 centimeter cubed. We did that, I don't know, probably 3 or 4 days ago. It's probably 4 or 5 pages back in your notes. So I can use that centimeter cubed right here to also show me milliliters. So in 1 milliliter of lead, I have 11.4 grams of lead. So my milliliters of lead cancels and I'm left with grams, which is exactly what I want. So I'm going to take 45.2 and I'm going to multiply it by 11.4. And when I'm done with that, my calculator gives me this. I started with 3 digits, so we'll do 3 digits. That 2 tells me to round down. So I'm going to call this 515 grams of lead. Okay? So, last but not least, what would be this? Well, actually, I think I have a couple more. What would be the same mass in pounds? So 515 grams. 515 grams. Did we have a relationship way back like 2 pages ago between grams and pounds? Yeah, we did. So let's use that. We want the grams to cancel out. So we're going to put the grams on the bottom. I have 454 grams in 1 pound. Okay, so my grams cancel and I'm left with pounds. So I'm going to take 515 and I will divide it by 454. When I do this, I get 1.134 and blah, blah, blah pounds of lead. I have 3 digits here, so 1, 2, 3. That 4 tells me to just leave it. So I have 1.13 pounds of lead in that block. Okay? All right, let's look and do another. When a piece of aluminum is placed in a 25 milliliter graduated cylinder that contains 10.5 mils of water, the water level will raise up to 13.5. So let's picture this. If I have a graduated cylinder and I have some water in here, and I'm going to make my water pink. So I've got some water sitting in here. And if I put something in it, let's get another color. If I put something in there, and let's say I have a little chunk of lead, that's going to make that water rise up. So it will make that water rise up. And the difference between the 2 levels of water, that difference is the volume of this object. So if I look at that, I can use the difference between these 2 measurements to get the volume of that piece of aluminum. So if I start with 13.5 mils and I subtract 10.5 mils or milliliters, let's see, 5 minus 5 is 0, 3 minus 0 is 3, and 1 minus 1 is 0. So I will have a volume of the aluminum of 3.0 milliliters. So we want to find the mass of this aluminum. I've been given the density of aluminum of 2.7. So remember, density is mass divided by volume, right? So if I want to find a mass, wouldn't mass just be volume times density? So let's start with my volume. I have 3.0 milliliters of aluminum. I want my milliliters to cancel, so I'm going to put my milliliters of my density on the bottom. So in 1 milliliter, I have 2.7 grams of aluminum. So 3.0 times 2.7, because my mils cancel, this will give me grams. 3 times 2.7, this gives me 8. Oh, that's a horrible 8. Let's try that again. 8.1 grams of aluminum is about how much that chunk of aluminum should weigh. So this is what we call a displacement, because I displaced the water to get the volume of that piece of aluminum. Okay? All right. Let's look at this. I've got a cube with a mass of 20 grams and a volume of 5. Is that going to be made of aluminum? Remember, density is mass divided by volume. So I'm going to take the 20 grams. I'm going to divide it by 5 centimeters cubed. 20 divided by 5 gives me a density of 4 grams per centimeter cubed. Remember, aluminum had a density of 2.7 grams per centimeter cubed. Are these equal? I don't think they're equal. That is not equal. So that means this block, because that density is not the same as 2.7, is not aluminum. Okay? It's made with some other metal that is more dense. Okay, we're going to call it good for today. We are going to work on some more density problems probably on Tuesday, and then do our lab maybe Tuesday or Thursday. So have a great weekend and enjoy. Talk to you. Bye.